Let's delve into some fascinating facts about total dissolved solids, TDS, and their intricate connection with water quantity. TDS serves as a key indicator of the concentration of solid substances dissolved within water, typically measured in parts per million, ppm, where 1 ppm is equivalent to 1 milligram per liter. For example, imagine starting with a 1-liter glass of water containing 2000 ppm TDS. This means there are 2000 milligrams or 2 grams of dissolved solids within that single liter of water. As this water evaporates, whether naturally or through heating, and its volume reduces to a half-liter, the quantity of dissolved solids within the water remains constant. The dissolved substances stay within the water. Only the water itself evaporates. Consequently, the remaining half-liter will still contain 2 grams of dissolved solids, which translates to 4000 ppm TDS when expressed in the standard measurement of 1 liter. Continuing this process, if the water further evaporates to a quarter liter, the TDS concentration doubles, reaching 8000 ppm. This vividly illustrates that as water evaporates, the TDS concentration increases. Moreover, TDS can be influenced through dilution. Consider starting with a quarter liter of water containing 8000 ppm TDS and adding another quarter liter of pure water. The resulting half-liter will possess 4000 ppm TDS. If you further add another half-liter of pure water, the resulting 1 liter will have 2000 ppm TDS. This principle extends to natural settings like stagnant water in a pond or tank. For instance, a pond with a small amount of water at 2000 ppm TDS will experience fluctuations in TDS concentration as water evaporates. It doubles when the water volume decreases by 50% and quadruples if it continues to evaporate by another 50%. Dilution occurs when fresh water is introduced into an existing water body, whether through rainfall or pumping. Throughout this process, the total dissolved substances within the water remain constant, but the overall water volume increases, leading to a reduction in TDS concentration. This dynamic interplay between evaporation and dilution is observed in natural settings such as lakes and in controlled environments like laboratory experiments with small water quantities. To attain a sustained decrease in total dissolved solids, that is TDS levels within a water body, it's essential to introduce additional water with a specific purpose. This serves to dilute the existing water and its dissolved substances. When this diluted water is utilized, it ultimately leads to improved water quality by removing solid substances from the equation. Additionally, the introduction of fresh water naturally contributes to further TDS dilution.